Look around you. The screen you are staring at, the car parked in your driveway, the planes crossing the sky, and even the clothes on your back. Almost everything that defines our modern existence relies on a single, buried treasure. A thick, dark, and highly combustible liquid hidden deep beneath the Earth's surface. Crude oil.
But bringing this black gold from a subterranean prehistoric vault to the gas tank of your car is not a simple task. It is a multi-billion-dollar symphony of extreme engineering, dangerous environments, and chemical wizardry. It requires machines the size of skyscrapers, pipelines that cross entire continents, and chemical processes that literally break the building blocks of matter. Today, we trace the epic journey of crude oil. To reach the oil, a heavy-duty drill string, sometimes equipped with diamond-studded bits, must grind through layers of solid rock. We are talking about drilling down 3, sometimes 5 miles into the Earth's crust. Once the drill pierces the reservoir, the immense natural pressure of the Earth takes over. It violently forces the crude oil up the pipe toward the surface.
Our journey begins not on land, but hundreds of miles out at sea.
In some of the most unforgiving environments on the planet, floating high above the waves are offshore drilling platforms,
mammoth structures of steel and ingenuity that function as self-contained floating cities.
When it arrives on the rig, it is a violent, toxic mixture of crude oil, natural gas, salt water, and sand. Before it can go anywhere, massive onboard separators spin and heat the mixture, stripping away the gas and water.
What remains is pure, unrefined crude oil. But the real magic happens when human engineering takes control.
Ready for export, the pure crude is channeled into the main export lines, moving thousands of barrels an hour towards the edge of the platform.
But this floating city is just a pit stop. To move millions of barrels, they need the titans of the sea. You cannot refine oil in the middle of the ocean. It must be brought to land.
Enter the Very Large Crude Carriers, or VLCCs. These supertankers are the undisputed titans of the sea. A single fully loaded tanker can be longer than 3 football fields and carry upwards of 2 million barrels of crude oil.
After weeks of navigating treacherous oceans, these behemoths finally reach their destination,
where massive, articulated robotic arms connect to the ship's manifolds. They arrive at specialized coastal terminals. Powerful pumps suck the oil out of the hull, transferring it into sprawling farms of storage tanks.
But the port is just a temporary layover to reach the refineries. The oil enters the silent, invisible arteries of the industrial world, the pipeline network.
Huge mechanical booster stations are positioned every 50 to 100 miles along the route.
They generate immense pressure, pushing the thick, heavy crude across mountains,
under rivers, and through deserts at a steady walking pace of about 3 to 4 miles per hour. Inside control rooms, operators monitor digital dashboards 24/7. Using acoustic sensors and fiber optics to detect even the slightest pressure drop. Finally, after crossing the continent, the crude oil arrives at its destination, the refinery. A sprawling, mechanical metropolis of chaotic pipes and extreme heat. In its raw state, crude oil is practically useless. You can't put it in a car, and you can't fly a plane with it.
It is a complex soup of different hydrocarbon molecules. To unlock its power, it must be cooked.
The first step is fractional distillation. The dark crude is blasted with heat exceeding 600 degrees Fahrenheit. The liquid furiously boils and turns into a superheated vapor. This vapor is then fed into the bottom of a towering fractionating column. Inside this tower, it is boiling hot at the bottom and cooler at the top. As the vapor rises, it begins to cool down. Inside this tower, it is boiling hot at the bottom and cooler at the top. As the vapor rises, it begins to cool down.
Because different hydrocarbons have different boiling points, they turn back into liquids at different heights.
The heavy, dense molecules condense at the bottom, but near the very top, the lightest and most valuable liquid condenses, gasoline.
But there is a problem. The modern world demands far more gasoline than the distillation column naturally yields.
To fix this, engineers use a process called catalytic cracking. The heavy, less valuable oils are taken to a cracker unit.
Here, under extreme heat, intense pressure, and with the introduction of chemical catalysts.
The long, complex hydrocarbon chains are literally snapped in half.
This molecular destruction transforms heavy, cheap oil into lighter, highly valuable gasoline molecules. The newly born gasoline is not quite ready yet. It is still corrosive and contains impurities like sulfur.
The liquid is sent through a hydrotreater, where hydrogen gas is injected to bind with the sulfur, safely stripping the toxic elements away. But engineering the perfect fuel is a game of microscopic precision. What emerges is a pure, highly refined, and perfectly engineered golden fuel. Before any of this fuel touches an engine, it must face the ultimate test of quality control.
Inside state-of-the-art laboratories, scientists and automated systems analyze samples from every single batch.
They test for flash points, emission standards, and the all-important octane rating.
Only when the fuel achieves absolute chemical perfection is it allowed to leave.
If the mixture is off by even a fraction of a percent, it could cause engine knock and destroy a modern vehicle.
Only when the fuel achieves absolute chemical perfection is it allowed to leave the laboratory's jurisdiction. The finished, golden liquid is now cleared for the final leg of its incredible journey. It is pumped into massive, pristine storage tanks, waiting in vast, silent reserves for the world's demand. These tanks hold the refined, highly combustible lifeblood of the global economy. Unlike the dirty crude at the beginning of our journey, this is pure energy, ready to burn. Unlike the dirty crude at the beginning of our journey, this is pure energy, ready to burn. The logistical ballot required to distribute this fuel is staggering. Alongside endless lines of railway tank cars, moving the fuel across thousands of miles.
Every single minute, thousands of these vehicles fan out across the highway and railway networks,
acting as the final delivery mechanism to cities, gas stations, and airports. Burning with incredible, explosive efficiency.
It powers the jets that connect our continents.
And fuels the massive supply chains that deliver our food.
The journey of crude oil is arguably the most complex supply chain ever created.
An invisible, roaring machine that never sleeps.
working quietly in the background to keep our world moving. It forms a delicate, intricate web of energy that wraps around our entire planet. But its journey doesn't end in our engines. This black gold is the hidden foundation of the modern materials we touch every single day. And as long as the world keeps turning, this invisible machine will never sleep.
This is the journey of black gold.